Okay, so let's start off pretty basic and simple and just take a nice little happy function of 3x. That's the derivative of some function. Our goal is to go backwards. So something I want you to think about is every time we're doing these problems, to make your life easier, I want you to think about rewriting, then you're going to integrate, and then you're going to simplify. Remember when we differentiated, we like to simplify first and then we differentiated? Same idea kind of applies here. And for this particular problem, when I rewrite, I'm going to make sure I look for that constant. So as a result, I know I can rewrite this with the constant out in front. Again, refer to page 286 for your anti-differentiation rules or your integration rules. We go from here. If it helps, we can put a little 1 as our exponent. Now remember, we're going backwards. We know with our power rule that when we differentiate, we subtract. Therefore, if we're going to do an integral and integrate, we're going to add. So I'm going to put this 3 out here. I'm going to add 1 to my exponent. But what's important is I also have to divide by that value of 2. Because remember that when I go backwards, if I differentiate this, I have to bring the 2 down and I multiply it to the constant that is in front of the x, and that needs to be a 1. And then, lo and behold, don't forget, because many of you will, you're plus c. We're not done yet because I do not want this problem in that form. I would like to actually see it simplified. So we're going to multiply that out. And there would be your answer. Okay, so we're going to go with the idea of rewrite, integrate, and simplify. Yes, we are going to rewrite this. We are going to rewrite this as x to the negative third. If we can use that power rule, then we're definitely going to make sure that we do that. There are no constants in this one. We don't have to worry about the 1. So to integrate this, we're going to take our variable. We're going to take our exponent. We are going to add 1 to it. Again, the opposite of what we did for the power rule. And instead of bringing it down and multiplying, we are going to divide. Plus c. Again, don't forget this. So let's simplify our answer. That gets me x to the negative 2 over negative 2 plus c. Still not quite good enough. Let's put our answer with no negative exponents. So therefore we can write this as negative 1/2 x squared plus c. What's nice is you can check yourself if you do the derivative of this function. Do you get this function that you started with? Then if you did, you know you're on the right track. Okay, next example. Rewrite, integrate, simplify. You've got a square root function. So I can rewrite that as x to the 1/2 power. No constant to put out in front, so now I'm just going to apply my rules. It is a power, so therefore I'm going to take that power, I'm going to add 1 to it, and we are going to divide by the result of that power. Again, plus c for that constant that we do not know. I'm going to add those together and we get ourselves 3/2. Forget my x. And I have 3/2. No, you would not leave that answer with a fraction within a fraction. Remember that dividing by a fraction is the same as multiplying by its reciprocal. So therefore when we simplify that, we get 2/3 x to the 3/2 plus c. For our last example, of course, we can't have any fun without trig, but first of all, notice that there happens to be a 2 in front of your sign. It is a constant, so we can rewrite that by pulling that out in front. We'll put it as part of our final answer, but we don't need to worry about it when we differentiate or anti-differentiate. Again, we need to know our differentiation rules because you have to know what did I derive to get a sign of x. So remember that the derivative of cosine is sine, or negative sign, pardon me. So when we anti-differentiate, we have to make sure that we include that negative as well. So then that becomes that 2. Antiderivative of that is negative cosine of x Oops, don't need that, but I do need a plus c. Plus c. Simplify, so I'll take that -1 and multiply that to the 2. And there's your answer.